So you're working on an electronics project and you get your meter out and put it on the bench and you reach to get your leads and you knock it over and they get all tangled up sometimes. This is a brand new meter, so it's not so bad. But you adjust it, and usually these are all tangled up, and when you go to get them over to your project, they wrap around something that falls over and everything gets all tangled up in a big jumbled mess. So today I'm going to try to solve that and also merge some of my hobbies. I started by taking some measurements of the multimeter and doing some drawings and sketching out some ideas that I had in my head as to how I'll go about the project. Now, some of you guys have been asking about the process to design something for a 3D printer, and I'm by no means an expert. I'm a beginner actually, but here I am just doing a sample mock-up of my project, and I start very rough, and then you actually end up printing different versions of it, different iterations, and then you have to remeasure it because the plastic can shrink when it cools. So some of your measurements, you try to get them as close as possible, but you do have iterations to get things to fit the way you really want them. And you just do stupid things because you're a beginner. You know, you mess up and it goes to print and you're like, oh, this is never going to print. This is not going to work the way I thought it was. But this is really only my second or third project here. So can't be too hard on myself. Now I made the original box there on the left and shelled it out. Now I made a cutout and I just did a fillet on the edges. And there's many ways to do this. I'm just doing whatever I see in my head would work. I basically will subtract or knock out that pattern from that. And that gives me, a good start. Now 3D printers use a plastic filament that comes on a roll, and it's not particularly expensive for the materials, but it is very time consuming. So what I started doing here is making little cutouts or knockouts in the side of the plastic, figuring that it would save on material and weight and hopefully print time because it doesn't have to print those areas, and it kind of makes it look cool too, but it really doesn't affect the structural integrity or the strength of the piece that much. Now what I did was I started out with a cylinder here, and then I just made an array of them, and that's a really cool feature. Then I group them all together so I can manipulate them all at once as a group. Basically grab on them, rotate them 90 degrees, and then just jam them into the side of the plastic here, let them come out on the inside. Just lining them up a little bit. And then there's a command that you can just subtract solids from other solids. So I just select on all these, and bam, knock the holes right out of there. It's pretty cool. Then I use something like the fillet tool and just grab some of the edges here and round them off. Just take off the sharp edges so you don't scratch your hands on them, and it makes it look more professional too. It's pretty neat stuff. Now you have to import the file you designed into slicing software. And this is software that basically takes your project and slices it into layers. And we'll see that here in a second. And it's basically going to emulate and show you how this thing is going to physically print the layers on the 3D printer. I'm just moving it around on the bed here to where I want it. And here's a whole bunch of settings you can get into, temperatures and speeds and everything of your plastic. It's very detailed. Okay, and here we go. So this actually generates how the slicing is going to work. Look at that. I can look at a layer at a time, starting at the bottom. I'll zoom in here a little bit, and it'll show you actually where the head's going to print in every layer from the raft the whole way up to the top. And notice up here in the corner too, it gives us some build statistics, how long it's going to take, about 4.5 hours, cost about $2.54 according to my material cost. Shows you how much material it's going to use. So that's pretty nice. And while it's cool to watch it print for a while, it gets really tedious. So I just kind of started off and let it go for 4 or 5 hours, and you can hear it from the other room. And when you come in, the tray lowers and your project is there waiting. It's like something out of a sci-fi movie. This is definitely an iterative process. You do a lot of versions. So this was the first one I did. I just, guessed at the sizes. I mean, I took a measurement, but I left some extra. And see, there was a lot of play in it. And I thought, okay, I'm going to have to do on the next one, I'm going to have to tighten that up a little bit. So, this then, not only is this a different material, but see, it's not as wide. And I think it's about the same height. And I think I shaved off about 1 millimeter on the depth. But now when I put him in here, see, he's a nice snug fit, just a little bit of play. And I think in the back, it's just a little, like 1 millimeter of play. So good. And then afterwards, I did a similar design and made a holder for the leads. And again, I just sort of thought this in my head, like how it would work. Kind of held the leads down and measured them. And that one I did, I think, in one iteration. Came out great. And here are just a few photos of the iterations in the final project. Now the white one was printed with a PLA material, but the gray one was printed with ABS plastic, which is more difficult to do and is more sensitive to temperature and shrinking, so you see some more lines in it, but it's still structurally sound. I mounted it to the shelf here with some wood screws. Do you see my mistake? Yeah, well, I got lucky. I can barely get in here with the screwdriver and tighten these up, but I'd have to think about that next time. The walls on this unit are thinner than the one on the left, so I didn't want to drive those screws home into the shelf. That's why they're sticking out a little, but they're fine. So let's drop our meter in. That's a nice fit. And just coil up our leads, jam them down in here. There we go. Now I left this gap in here. I could have jammed it right together, but I left the gap figuring that might be a nice place to put some wires or stick something in there that needs to be retained. So you want to use it, you just reach up, turn your meter on, grab your leads out, take your readings, shut it off, everything's up out of the way. I could still see it from the workbench. Well, I hope this has been informative and entertaining, and I hope you enjoyed it, and thanks for watching.